So I want to just hit on a couple of these. I mean, you've mentioned a lot of these differentiators already. So maybe just take us through like why you decided to create a full stack. So you recognize this is an issue, but you're actually creating sensors, controllers, controller
Right.
software, cloud software, the whole gamut. So why'd you decide to do that?
The primary reason is like I look at the controls industry as kind of like the computing industry back in the 70s. Right? Back then when you bought an Apple One, you brought it home, you soldered it together, and then you learned programming in BASIC to solve your own problems. Right? And today it's inconceivable to not walk into a mall and you want to buy an iPhone in 3 minutes. Of course, you can't walk into a mall these days without wearing a face mask, but that's if you can, if
Whole
you
separate
can at all.
story.
So this is a different story, right? And but if it ever takes you 5 minutes, you're probably screaming bloody murder. It's like that. This thing
Uh-huh.
is bad, right? But it's kind of weird in the controls industry. We still accept that system integration and taking a product from Schneider and then taking another sensor from ACI and then tying them together through custom code is acceptable,
Right.
right? And that to me is kind of weird. It's part of it. Yes, standards exist for interoperability, but they also make it harder that nothing works out of the box, right? And if you look at it, I mean, the standards, I believe, don't necessarily need to exist at a device level. Really, if you want to have these days, I mean, the system should work out of the box. I mean, you don't really care what standard your iPhone camera uses to communicate with the rest of the processor. What
Right.
you do care is about the base level functionality and like how does it interact? Like, is the file system which is supported, is the photo a JPEG or a PNG, which can be exported out of the unit, right? So if we accept that kind of modularity, I mean, if we accept that that is a black box, then that really allows us things to be more efficient. Not everything needs to be interoperable at every stage, is how I look at it,
Okay.
right? So our take was that, all right, let's make sure that instead of saying that the humidity sensor itself needs to talk backnet and go right to a controller, let's make sure that the humidity sensor and the temperature sensor and the volatile organic compounds and the CO2 sensors, let's not even make them optional, right?
Right.
Let's put in all of these sensors out of the box. And because the hardware has grown, in all honesty, to be super reliable and cheap, right? We end up using the same sensors. When I started originally on the residential side, I mean, we used the Fluke temperature sensors were about $350 to get a reference quality Fluke sensor. We have the same sensor in every one of our rooms now,
Wow.
right? So overall, if you look at just how, and it's part of the mobile revolution, right? I'm not taking credit for it. What I'm saying is that, I mean, the consumer electronics have really driven, the mobile revolution has driven such good standards in terms of sensors and overall technology that what we really need to do is keep pace and take advantage of that. And that's what we're doing. We're packing all of these sensors, packing in all of this functionality out of the box, right? And the second piece that we wanted to do is we wanted to have that instead of having a dedicated application specific controller, that you have one controller that takes on different personalities depending on what equipment you connect it to. So it's kind of like your iPhone is one box. It's got all the sensors, got all that functionality baked in. Depending on what app you're using, you end up having a different profile, right?
Totally.
So
Yeah.
because the value is in not necessarily going and integrating and putting these things in one at a time. So it's not unique in terms of what the industry is doing in the consumer side, right? We accept this in our phones, we accept this in our cars. We've just not somehow got it in our HVAC and our buildings yet, right?
Totally.
We look at the totally integrated scenario. Nobody talks about is like, hey, is my car talking backnet to the next car?
I agree. Yeah. So it sounds like also one of the benefits of it being full stack is it's also super easy to install. All right. I mean, like you kind of hinted at with that with the iPhone example, but it can be very quick, right? And I think that's one of the things you guys were going for initially too, right?
Right, you're spot on with that, right? I mean, that was the whole idea that we wanted to make it very easy. But back to my roots, I was really thinking that like, why did this control solution in our home not work? And it's primarily because we made it overcomplicated. We've got all these pieces to tinker around. We're not looking at it as a solution. We're really looking at small pieces that needed to be brought together. So we had this paradigm. We did a project in an elementary school, and we asked the kids who were 8 and 9 years old to go put in our system ourselves, right? So the idea is that, so we always have this thing. I mean, our system's gone, in all honesty, a little bit more complex now. We're doing much larger buildings. We're doing 1 million square feet sometimes, right? But so maybe the same students could do it now, right? A little bit older, 10 and 12-year-old kids could do it now. But at that point, it was revolutionary that you could go put in a control solution that the kids who had no training at all could go put it in. And we've kind of kept it as part of what we look at when we add features is like, does it increase the complexity and the debt in terms of cognitive burden on the person who's installing it, right? Because you can give all of these options, but the more options you add, the harder it becomes to actually use. Right? So like your grandmother, is pretty hard for them to pick up an iPhone these days and use it out of the box, right? It works out of the box, but if you ever went to settings and try to configure a thing, I think it's a little bit more complex than the initial system, right?
Yeah.
So we've been pretty mindful about that. Is like, how do you hide all of that complexity and make it so that the machines can do that, right? So I think we were talking about Descript, right? All the things that you can do with Descript. I mean, that's absolutely amazing. To try to do that by hand would be nuts, right? And yet that compute power is available. It's abundantly available, and all you got to do is harness it.
Right.
Yeah,
Cool.
so that's what we did. Is like, let's harness the technology curve very aggressively, because the way I look at it is like purely from an energy efficiency perspective in terms of the CO2 emissions. If you look at where we are not, our CO2 levels and our GHG is not rising linearly, it's rising exponentially, right? And so the only thing that I know of that we can actually use, the only other thing to counteract that is Moore's law, right? Like, our compute power is the only other thing which is non-linear that I know of in terms of technology. So we got to be very, very aggressive in making sure that we are always keeping ahead and keeping track where technology is, right? And making sure that we have very aggressive price points for compute.